Have you ever heard anything bad?
First one.
Usually, if it's anything bad, it's been me.
Really?
Unfortunately.
Let's do.
Okay.
Mrs. Ford?
Yeah.
Do you have an extra packet? I don't think it was
If I do, it's over there in the lower left column. All right, so here we go.
And Molly, see if they got.
Here we go. Our job is to find the vertical asymptotes, horizontal asymptotes, and holes. We have done this before. What is our strategy? How do we begin? We factor. Let's see. A 2 will come out of the top. And the bottom is x plus 3, x minus 3. And the top can factor more. How does the top factor? X minus 3, x plus 1. And what do we notice about that? We can cancel, which immediately tells us what? We have a hole in our picture. So before I go any farther and end up forgetting, I'm going to take care of figuring out where that hole is. The hole will be at whatever factor you canceled out. So x will be 3. That's the factor we canceled out. Now the hole, remember though, kids, is a point. It's an open point. So I need a y coordinate. Where am I going to get the y coordinate? I'm going to plug in 3. Where am I going to plug it in? For x. Where? X where? What equation? That one. Don't go back to the original, because if you go back to the original, you're going to get a 0 in the bottom. You've got to plug it in your new problem. Okay? So, plugging 3 into my new problem gives me 2 times 4 over 6. Putting 3 in, which is 8 over 6, which is 4/3. So I am going to have an open circle at 3, 4/3. That's where my hole is. Does every equation have a hole? No. The only way you can have a hole is if you cancel. You can factor, you can have tons of stuff, but if nothing cancels, you're not going to have any holes. Now, what about asymptotes? Tell me about the asymptotes. What?
The one problem that was better for parentheses.
Well, the asymptotes had to do with, yeah, these things. Where do I put a vertical asymptote? What x can't be. So look at the problem. What can x not be? -3. So you're going to have a vertical asymptote at x equals -3. Now, in the beginning, it looked like there might be 2 vertical asymptotes, but one of them canceled out, so we ended up only having 1. Okay, how about horizontal asymptote? No. Now, -1, we're not ready to graph this yet, Braden. That would be an important point. -1 is actually the x-intercept. That's what makes the fraction equal 0. That's a 0 of the function. That's not the horizontal asymptote, though. Where's the horizontal asymptote? At 2. And why is the horizontal asymptote at y equals 2? Because 2x over x reduces to 2. That's your horizontal asymptote. Number 2, I'm looking at the quiz. Number 2, what's the domain? Say it louder, Thomas.
X is greater than.
X is greater than or equal to 2. Now, those of you that are still in La La Land, remember, if it is under a radical, it must be greater than or equal to 0 every single time. Doesn't change. So if x minus 2 has to be greater than or equal to 0, then x has to be greater than or equal to 2. That's your domain. Those of you that want to do it mathematically will have bracket 2, infinity parentheses, right? Number 3, list all the graphs that are even. Which ones are even? A and B. Because what does even mean?
Y-axis symmetry.
Y-axis symmetry.
Thank you.
Which graph is the absolute value? B. Everybody knows that, right? One of the kids told me today, this is so simple, I'm sure somebody's told me before, but I forgot. Absolute value V. Number 5, which basic graph is D? That's the cubing function, so if you use words, you'd say cubing function. If you used equation, you would say y equals x cubed. What is C?
It is the sine.
That's the sine function, goes through the origin, that's what the sine does. And then our bonus question, what impact does the 2 in this equation have? Pay attention to where it is. I'm not talking about the squaring 2, I'm talking about the 2 in the parentheses. What impact does it have? It goes to the right 2 units. So what shape would it be?
Maybe a
A
parabola.
parabola, 2 units to the right. Very, very good. Now, on the back of the first page, the typed thing that I stole from Mr. Thompson. Find the domain. Thank you, sweetheart. Find the domain. All right, here we go. Number 1, what's the domain? Somebody said it.
All reals.
All reals. Kids, I'm going to say this one more time, and I want you to listen. This is really important. No radical, no denominator, no issues. Unless it's something funky like a logarithm or, a weird thing. If it's a regular problem, no radical, no denominator, no issues. Does this problem have a radical or a denominator? No. Its domain is all real numbers. Now, what about 2?
All real numbers.
Number 2.
All real numbers.
No. 2 has a denominator.
What page are you on?
I am on the back of page
I wasn't
1.
even on that.
The typed one.
You had to get traded for that.
Put them on the JD then. All right. Number 2. It has a denominator. So what can you tell me? X cannot be what?
7/4.
Negative 7/4. And for those of you that can't do that in your head, it's okay. Just say 4x plus 7 cannot be 0. The denominator cannot be 0. So 4x cannot be negative 7 and x cannot be negative 7/4. How about 3?
X cannot equal -2.
X can't be negative 2, but there's more. Wait, it can be negative 1. There's no issue with a 0 up top. What is there an issue with? A radical. What do we know about radicals? Whatever is under them has to be greater than or equal to 0. So x plus 1 has to be greater than or equal to 0, which means x is greater than or equal to -1. Now, what was the other piece you told me? Can't be -2. Now, wait a minute. I'm not going to take points off if you write both of those down, but do you really even need this one? If you're telling me x has to be bigger than -1, then will -2 even be a consideration? No. So the best answer is that. You don't need both of them this time because they don't match up. Number 4, find all the asymptotes and holes. Okay, we just did this, but let's do it again. How do we start? We're finding all the asymptotes and holes. What do you want to do first? Factor. And the top factors as what? Plus 2 plus 1. Yep. And the bottom factors as? Minus 3 plus 2. Perfect. Good job. Horizontal asymptote, vertical asymptote, hole. Are we going to have a hole this time?
Yes.
Yes, because x plus 2 cancels out. So here's my problem. This is what I'm down to. But there's going to be a hole where? -2. Everybody see where I'm getting -2? The hole comes at whatever cancels out. Right? There would have been an asymptote at -2, but now there's not because it canceled, it's gone. So you have a hole instead. He even put the word down there, removable discontinuity. You removed it. Now how do you get the y coordinate? Plug it in here. So putting in -2, we'd have -1 over -5, which is 1/5. So if you were graphing this, you would put a little open circle at that point. Vertical and horizontal asymptotes. Look right here. Beady-little eyes. Focused right here.
Vertical is 3.
Vertical is x equals 3. Because what happens if you put 3 in? 0. Not allowed to do that. Cannot be. These are vertical asymptotes. X cannot be 3. What's my horizontal asymptote?
Y equals 1.
Y equals 1. X over X. Skipping to number 8. If you plug in -2, you get -1 over -2 minus 3. That's -1 over -5.
So you plug in the x that you get for the whole equation, and that gets you the 1.
Yes. Yes.
Can you explain the horizontal asymptote again, like how to get it?
Build a fraction of x's over x's.
So you just ignore whatever's there.
Okay, remember, we're talking about letting x be big. A horizontal asymptote goes off the page this way.
Yeah.
If x is 1 billion, the top would be 1,000,000,001,
Yeah.
and the bottom would be 1,000,000,000 minus 3. Now, aren't those numbers pretty close to the same? Yeah. So I ignore it, because in terms of billions, 1 and -3 mean nothing. Only thing that matters is billions.
You just ignore it.
Yes. Now, will that fraction ever equal 1? No. But the bigger x gets, the closer it's going to get to 1. Okay, now we're going to number 8. We're looking at number 8.
Squared over x, then
On what intervals are we increasing or decreasing? Now, what are you probably going to need to do before you can answer that question? Graph it. Now, luckily, and this will be the case because this will be a no calculator question. This will be part calculator, part not. This will be a not, because this is a form of the absolute value, and we all know what shape the absolute value has, right? It's a V. Now the normal one would be positioned at the origin. But what have we done to this one? We have moved it 2 units to the left and 3 units up. So now, instead of V'ing from the origin, it's V'ing from here. This is -2. Everybody okay with that? Now, this question says increasing, decreasing. So we're talking about moving left to right Is our pencil going down or is our pencil going up? Well, it's doing both in this picture, right? So where is it decreasing? I need an interval now.
Negative infinity.
Negative infinity to negative 2. I'm talking about moving left to right, so I'm looking at x values. Negative infinity to negative 2, my pencil is going down. Then, at 2 on, my pencil is going up.
Negative 2.
Negative 2, thank you. And remember, we never bracket, like the negative 2 in this case, because at that one instant point right there, the curve isn't going up or down, is it? It's changing direction. So it's never included. Number 11. Determine whether it's even, odd, or neither. Now, this is going to be a no calculator question. Could you make the determination by graphing it? Absolutely. But remember, you'd be graphing without your calculator. I'm not sure we're ready for that. That might take us a very long time. So let's go back and think, what does even and odd mean? What does even mean to the mathematician? Symmetric about the y-axis. So I need to check my y-axis symmetry. What does odd mean? Origin. So I need to check those two symmetries. Who watched the video and can tell me, because I went through and did an example of each symmetry, who can tell me how we algebraically test y-axis symmetry?
Change the sign on the X.
Change the sign on the X. I love you, whoever said that.
I love you too.
Change the sign on the X. So, I'm going to take my equation, remember this is y. I'm going to change my sign on the X, so it'll be negative 2 negative x to the 4th plus 3 negative x to the 2nd. So all my x's, I change the sign. And if you think about it, that makes sense. If I'm the y-axis, and you have a point over here that's 2, 3, then won't this point over here be negative 2, 3? You change the sign on x. Now, what happens when I do that? Well, what happens to this negative? It does not cancel with this one. It becomes positive because I'm raising it to the 4th power. So this is still negative 2x to the 4th. What about that negative? It gets squared out, so I have plus 3x squared. Now, compare that to the original problem. What do you notice about it? It's the exact same. And when it's the same, we have symmetry. When the equations match exactly, we have symmetry. Now I'm going to go ahead and do the origin, just for practice. What's the test of symmetry for the origin?
Change sign on both.
Okay, we change the sign on both. So we'll have negative y equals negative 2 negative x to the 4th plus 3 negative x squared. Now those of you that are seeing that for the first time, shame on you. You gotta watch that video. Okay, now simplify. What happens? Well, we have negative y equals, okay, we already talked about this. That's going to be negative 2x to the 4th plus 3x squared. But now I got to get rid of that negative, so y will equal 2x to the 4th minus 3x squared. Now, if I'm going to have symmetry, what has to be true of that? It's got to match the original exactly. Not close, exactly. Do these match? No. So there is no symmetry about the origin. So this function is even. If you have a simple little function, like, you know, the absolute value, and you can visualize that, and you say, well, yeah, that's symmetric about the y-axis, that's okay. You don't have to do this test if you know graphically that it's got symmetry. You only use these tests when you really don't have time to graph it or you don't know how to graph it. Then the test will give it to you. Okay? All right, now I'm looking at 14. Determine the boundedness. This is kind of like the one that was on your quiz. Right? Now, everybody in the room needs to know that y equals e to the x looks like this. That's y equals e to the x. Now, what are we doing here? It's going down 4. That means everything's going down 4, including the asymptote. So the asymptote that used to be the floor was at 0. That 4 is now going down to -4. And the point that was at 1 is now at -3. There's a picture of it. Now you can tell me how it's bounded. It's not bounded above, right? But it is definitely bounded below at y equals -4. Find all local and absolute maximums and minimums. Okay, so 16. What shape is 16? A parabola. Your parent function is x squared. It's a parabola. What have we done to this parabola? We have shifted it left 2 and up 5. So you have a parabola, left 2 and up 5. Looks like that. Now, when we talk about mins and maxes, we're talking about tops of hills, bottoms of valleys. This problem has no maximums. Would you agree with that? None. However, it does have a minimum. And what would the minimum be? The point -2, 5. That is an absolute minimum and a local minimum. Any bottom of a valley is a local minimum. The lowest valley is the absolute. Well, I only have one, so it's both. Number 17, same question. What shape do I have here? I have a V. And where is it V-ing from? It's not the origin anymore. I moved it.
-2, 5.
Isn't it just like this one? Only it's a V. So the answer is the same. There's no maximum, and the minimum, absolute and local, is at the same point. Oh my gosh. Look at 18. Okay. Remember, on your normal sine and cosine, how high and low does it go? It goes up 1 and down 1. You need to know that. You need to know that. And we know by test day, we need to know these labels too. Okay. That's my normal curve. That's the sine. Now tell me what's happening in problem 18. Be careful. Which way are we going? Not going left. We're going up. Now, remember, if we were going left, it would look like this. Remember, if you're gonna go left and right, whatever you're doing has to be hooked right with the x, grouped with the x. This is not. This is sine x plus 3, which is going to do what here? It's going to take every one of those points and do what? Move it up 3. So instead of oscillating across the 0 line, we're coming up here to 3, and that's where we're oscillating. So would you agree that we are oscillating between 2 and 4 instead of -1 and 1? Now, these labels haven't changed. These are the same. So the directions say find one minimum and maximum. Because obviously, how many minimums and maximums are there? Infinitely many. So it says find one. So let's just, there is a maximum. Do you agree with that? What are the coordinates of that point? You have to give the coordinates. There's a maximum at pi over 2, comma 4. Now there are many other maximums, but there's one. Pi over 2, comma 4. Where is there a minimum? Maybe 3 pi over 2, comma 2? But there are other ones you could use too, but that would be an
So you need
example.
one of the left sides too.
This minimum would be negative pi over 2, comma 2. Number 19, describe the end behavior using limit notation. That's the only way we've done it, so of course you're going to use limit notation. What is the end behavior of the function y equals e to the x plus 3? Now this is like the third time we've done this function today. E to the x, we know what it looks like. So I'm going to move it up 3. So instead of the asymptote being here, it's going to be here. That's the point 0, 4. There it is. Now what is its end behavior? That's the limit as x approaches infinity on the right, and the limit as x approaches negative infinity on the left. Okay, we're almost done. We're going to go to lunch. Then you'll be done with me for the day. How about that? But this is good review. All right, so what happens as we go that direction? What is my function doing? Shooting up into space, so that end behavior is positive infinity. Now, what is my function doing as we go this way, toward negative infinity, out this way? What is my function doing? It's coming down. But it's not going to negative infinity. What's it going down to? 3. From the top. Remember, you can approach 3 from the bottom or the top. Hey, we're not done yet. Don't pack up. We've got a couple more to do. Number 22. Find the range. Range for me is always harder than domain, but I can usually figure it out if I have a picture. So here's my function. Now, do we know what that looks like? That looks like this, right? Now, what happens when we stick that +5 on the end like that? It goes up 5. So instead of being at 0, 0, it's now going to be up here at 0, 5. Same shape, but now it's up at 0, 5. So this isn't here now. Now pay attention, that's different than this equation, right? This would go 5 units to the left. tell me about the range of this picture. Tell me about the y values. Marty?
Range would be 5 to infinity.
Exactly. If you wrote it as minimal, 5 to infinity. That is perfect. Is that okay with everybody? All right. So everybody's clear on, okay, we're gonna have a quiz. Y'all hear tell you that? Tomorrow, we're gonna have a quiz. Quiz is gonna be over all this kind of stuff. So we just did a lot of review. Tomorrow, if we have class tomorrow, which I think we do. Okay, so we're gonna have a quiz tomorrow. All right? We're gonna have a test, go over everything we talked about so far, 1-1 to 1-4. Not a big deal, just random problems like these that we've been doing to make sure you're getting the concepts. Homework due on Friday, test on Tuesday. Got it? Have a good lunch. If you have not signed up for Math League, you need to get that done.